Assalamualaikum and salam sejahtera. My name is Faris Ikmal bin Mohd Noor and my supervisor is Dr. Suriati binti Akmal. Today I will be presenting my final year project and the title is The Development of Modern Batik Production Technique Using CNC to Enhance Batik Process. This is the presentation outline from my presentation today. Introduction. In general, batik production in Malaysia use traditional production technique. Traditional production technique has three main types, which is batik screen, batik block and batik canting. Kansai engineering, or also known as emotional and effective engineering, is the development of products by translating psychological feelings and needs. CNC system is used to propose modern batik production technique, and the batik production concept used in this research is batik canting. Problem statement. The first is, current Malaysian batik design has no unique identity. Secondly, traditional batik production is time-consuming and has small capacity of production. Objective. To propose modern batik production technique, we have identified a few objectives for this research. The first objective is to investigate the design of batik that influence human effective by using Kansai engineering. The second objective is to transform the batik motif in a computer-aided design software. And the third objective is to propose modern batik production technique using computer-aided design software for generating G-code. Literature review. The first topic is batik production. Batik production is categorized into two types, which is traditional and modern. Traditional batik production consists of three techniques, which is batik block, batik screen, and batik canting. Modern batik production uses batik printing technique. The next topic is the challenges of batik production in Malaysia. Batik production in Malaysia face some challenges such as imitation of Malaysian batik, modern batik production technique that threatens the originality of batik. Traditional batik production technique is time-consuming and has small capacity, shortage of batik artisan, and health safety issues. The next topic is batik motif. Batik motif in Malaysia consists of four main types, which is flora, fauna, geometry, and abstract. The most popular batik motif in Malaysia is flora motif. Based on a research paper by Anitawati Lokman 2018, this is some of the Kansai words that relevant to textile that are used in this research. There are a total of 20 Kansai words. By literature review, we have identified 8 designs of batik motif to be used in this research. Design 1 and Design 5 is flora motif, Design 2 and Design 7 is fauna motif, Design 3 and Design 6 is geometry motif, while Design 4 and Design 8 is abstract motif. Methodology. The first step is literature review. Next, we identify the challenges of Malaysian batik industry and we analyze human effective Kansai words. After that, we analyze existing batik motif and identify Kansai words that are relevant to textile. Using the identified Kansai words, we develop a questionnaire and distribute the questionnaire to respondents from all over Peninsular Malaysia. If the questionnaire is reliable, the questionnaire is then analyzed with factor analysis by using SPSS statistics software. From the factor analysis, the most effective batik motif is now identified. The most selected batik motif is then designed by using CAD software. Next, G-code is generated by using CAD software from the batik design. If the G-code is satisfied, modern batik production technique is proposed. Result and discussion. First is the investigation of batik design that influence human effective using Kansai engineering. Determination of batik properties. The method that we use is online distribution method through social media such as Facebook, WhatsApp, and Instagram. The period of the distribution is 1 month, and data analysis is performed by using SPSS statistics software. The number of respondents is 120 by random sampling, and the location is in Peninsular Malaysia. This is the result of the reliability test. According to Josh and Mallory in 2003, Chrombuck alpha value of 0.7 and higher is acceptable, while Chrombuck alpha value of 0.9 and higher is excellent. So based on this result, we can conclude that all design is reliable and excellent. Next, the result of demographic section of the questionnaire. The first question is gender, and the result is more female than male. The second question is age, and the result is most of them is 41 years old and above. The third question is hometown. The result is most of them is from Kedah, and the fourth question is education level, and the most is undergraduate. The fifth question is monthly income. Most of our respondents' monthly income is more than 3,000 ringgit. The sixth question is how frequent do you wear or use batik product? Most of our respondents use or wear batik product monthly. The seventh question is, do you know the differences of Malaysian batik and imported batik? And the answer is, most of them know the differences of Malaysian batik and imported batik. The eighth question is, which batik product process do you prefer? And most of the respondents prefer canting batik process. The next question is, what are the main factors that you consider in batik product before buying it? And the main factor is design. The next question, why would you buy batik product? So the most answer is the appreciation of local product. The last question of this demographic section is how much the price of batik product that you will consider buying, and the most answer is less than 100 ringgit. This is the result of the validity test. In order for the result to be valid, the R count value must be more than R table value, and the significance value must be less than 0.05. So, according to this result, all consecutive is valid. KMO and Bartlett test. The criteria of KMO and Bartlett test is good value of KMO measure of sampling adequacy must be more than 0.5. The good value of Bartlett test of sphericity must be less than 0.05. Based on this result, design 6 of KMO MSA is less than 0.5. Therefore, design 6 is discarded from this research. This is the result of the factor analysis. From this analysis, we can identify the most effective batik design that influence human effective. So based on this result, design 2 is chosen as the most effective batik design because component 1 in design 2 with the keyword of attractive has the highest value, which is 0.95. Therefore, design 2 is chosen as the most effective batik design. Transformation of the batik motif in a CAD software. The most effective batik motif, which is design 2, is then designed in a CAD software. In this research, the CAD software that we use is Autodesk Fusion 360. This is the completed design of batik motif from design 2. Modern batik production technique using CAD software. After the designing process, we perform a CNC simulation using Autodesk Fusion 360. This is the CNC simulation video from Autodesk Fusion 360. The machine that we use is generic 3-axis CNC milling. The process that we use is 2D engrave. The tool that we use is engrave mill or chamfer mill. The diameter is 1 mm and the taper angle is 30 degree. The feed rate of this process is 1000 mm per minute. This is part of the G-code that are generated from the CNC machining process. Conclusion and contribution. In conclusion, butterfly design, which is design 2 with keyword of attractive with the value of 0.95, is identified as the most effective batik design selected by Malaysia citizens. Computer-aided design software such as Fusion 360 by Autodesk can be used to transform the drawing. The G-code is generated to modernize the production technique by using CNC machine. This research can reduce time taken to design batik motif in traditional way. By collecting design in CAD, artisan and batik producers can innovate the motif according to customer preferences and current trends. That's all from me. Thank you.